Hello world, it's Siraj, and I'm going to talk about a topic I very rarely talk about. It's called esports. So esports refers to any kind of online gaming related to tournaments and players earning rewards. It could also be related to fantasy football, fantasy basketball, or even real life sports. But the idea is that you consider a game with other players as a kind of sport, and there is some reward involved. And specifically, I'm talking about this because there is this great intersection between cryptocurrency and esports. So I'm going to talk about 4 different tokens in this space that are intersecting these two spaces very well. And along the way, I'm going to explain how proof of stake works. So it's really hard to find any kind of readable proof of stake code, but this is a great way to do it because one of these coins actually uses proof of stake, and I'm going to use that as a segue to talk about proof of stake. Also, I'm going to talk about how token sales work because 2 of these coins do that really well and very easily. So if you want to make your own coin related to esports or gaming or any of the above, then it's easier for you to do so. So this market is growing very, very fast. If we look at the data, the revenue from esports, by the way, it's really a newer thing, esports. And the revenue from esports is growing like at a staggering rate every single year if we look at this graph right here, right? In the past 5 years even, it's gone from 0.5 to 1.5 on this CAGR scale. And the audience is growing as well. So millennials, my generation, and even the generation that's younger loves esports. So it's just gonna grow over time. The core audience, the data shows globally, is 85% male. Okay, so it's between 16 and 36-year-old males and they have an average household income of about 75,000 US dollars. So there was a survey of over 1,000 video gamers in the US, and they were asked a bunch of questions about cryptocurrency. These were gamers, by the way. So 75% of them said they wish they could exchange their virtual goods for currencies that they could buy and sell on other platforms. So generally when gamers are earning tokens inside of a game, they can only spend it within the game. But what if they could spend it outside of the game? And that is really the key for where cryptocurrency can play into video game based assets. 2/3 of them want more opportunities to use cryptocurrency within their video game network, and 55% of millennial video gamers own cryptocurrency. So that's a lot. That's more than half of millennial video game players own cryptocurrency. So there's a huge market for this. And why do they want this? Well, it turns out that it's easier to use, there's low exchange rates, and there's heightened security, right? Because there's a blockchain involved. So there's some more stats, et cetera, but the point is that this is a new class of digital asset, and it's all powered by cryptocurrency. So there was an esports tournament recently that was held online, and the prize pool was worth 100,000 US dollars. This was a big deal. So you can consider the gamers who trade in-game virtual items, also called skins in this case, to have a similar experience to cryptocurrency traders. They both deal in digital property, they both face risks involved with trading online, and they both have concerns about the security of their online wallets. Here's a picture of a popular tournament in Korea. So the first coin I want to talk about is XP coin. So we can go to its website here, xpcoin.io. So they say it's to incentivize rewards through using this digital currency. So I did a bit of research on XP Coin, and they partnered with a bunch of people. They partnered with Global Esports, Cooler Master, Red Bull, Nvidia, Twitch, Zodac, Razer. So there's a lot of companies that have partnered with this coin. And that seems to be key in the space, to partner with these leading brands that can then promote your token to the gamers worldwide. And ideally, these companies have gamers that are already embedded in their communities. They now have the #1 Overwatch team in India, so that's top 10 in Asia. They're developing an esports arena in Asia with a bunch of high-end PCs. So once you have this network built, once you have this community, then you can use the token to fund these things like a physical place. You can use it to fund tournaments. You can use it to fund different things. And the community can even use these tokens to fund their own things. So you can have essentially a decentralized movement that the creators of the token, they just kind of set rules into the protocol and then let it flourish and then let the community take over from there. But they're working on an e-commerce store as well where you can purchase all sorts of in-game assets and items. And this network that they've built consists of a bunch of roles. So this is a very important concept when creating any kind of community. When you have your token, you don't just want to have an ICO and just say, buy this coin, etc. That's it, and we're going to use it. You want to have some kind of role set for your community. So it's best to think of this beforehand. right? So they've got they have this idea of a super node and a dev node and a sales node and a geo node, a master node, and all of these nodes have different roles in the community. For example, the sales node will receive XP coin in return for selling some kind of experience or sales related product. The dev node is going to be related to development. The super node is kind of getting money from the other nodes to maintain the network. Geo nodes are location based. So as long as you have these roles and they're clear sets, people will take them up. You've got to have a good plan in place for your token to actually take off. You can't be in it just for the money. There's got to be some value that you're providing or your coin will tank, and the market will decide for you. So what they did was they forked Purecoin. So Purecoin was a fork of Bitcoin that implemented proof of stake. And this was a really good idea because proof of stake is the way to go. Ethereum's using it, or they're going to start using it, and the whole space will start moving towards proof of stake because it's more energy efficient and it's just a better system in general for security purposes. Proof of work is being consolidated by a bunch of big GPU farms, right? So the idea is that proof of work prevents any kind of 51% attack because you'd have to have a lot of computing power. But the problem is that 2/3 of the network is owned by a few entities. So there is a centralization when it comes to Bitcoin's proof of work algorithm. So the way out of this is by using proof of stake. And that's what Purecoin uses, that's what XP Coin, they forked off of it. But what I want to do is take this opportunity to segue into proof of stake and how proof of stake works, right? Because they're using it and it seems to be a very good protocol. It's getting more and more popular. So you might have heard a lot about Ethereum's Casper. If you're into Ethereum, the word Casper is showing up a lot in forums and Slack channels and all this stuff. But basically what Casper is it's a version of proof of stake. It's the latest version and they plan on implementing it very, very soon. But it's a 4-step process, Casper, and it's the proof of stake process. So step 1 is the validators stake a portion of their ethers. So the validators of the network are confirming transactions, right? And they're getting paid in Ethereum. So what they'll do is they'll stake a portion of their ethers, like whatever X is. So we can define that in the protocol. So let's say I've got 100 ethers. I'm going to stake 10 of them. Okay, so that's step 1. I've staked 10 ethers. Step 2 is that after that, they'll start validating the blocks. That's confirming that these transactions are valid. When they discover a block that they think can be added to the chain, a proper valid block, they will validate it by placing a bet on it. Okay, so they'll say, okay, this is very likely a valid block. I'm going to bet that it is so. If the block gets appended to the list, to the blockchain, then the validators will get a reward proportionate to their bets. So the more you bet on a block, the more a validator bets on a block, the higher the reward is, right? So if the validator acts in a malicious manner and tries to do nothing at stake, they'll immediately be reprimanded and all of their stake is going to get slashed. So that's kind of the security mechanism here, right? Because a validator, in order to say a block is valid or not, has to stake some of their coins. And if they're trying to defraud the system, then their stake that they had to put into this, essentially an escrow-like service, will be wiped out, and then they won't get to get that money back. So in order to vote, you have to have stake in the network. And if you try to do something bad, if you try to say a transaction was valid and it wasn't, then that stake goes away. So this is really the best pseudocode that I could find. It's not even pseudocode, it's just Python, but it's the Ethereum Casper script. And what we're gonna do is we're gonna take a look at it. It's about 400 lines, so it's quite a lot, I know. But let's just try to understand how this works programmatically, right? We know the basic idea that we have a set of validators in the network. They're gonna put some amount of ether at stake. They're going to vote on whether or not a block is valid. And if they are correct, then they earn some money. If they're not, if they've tried to defraud the system, then they're going to lose that stake. So that's the basic idea. So at the start, we're going to define all of these variables. There's quite a lot of variables here. So in here, we have this concept of a dynasty. So validators are grouped into what are called dynasties, and dynasties are groups of validators. It's just a way of segmenting up the network to improve the speed of transactions and of voting on whether or not a transaction is valid or not. There's a bunch of historical checkpoint hashes. So checkpoints in this case are just meant to speed up transaction validation, right? Because if we have a checkpoint, a validator doesn't have to validate every single block that came before, right? We can just have this checkpoint and say, starting from here, start validating onwards. So it just speeds up computation in the network. If we keep going down, there's quite a lot of variables, but I think the best thing for us to do is to look at the main code, just get an idea of the programmatic implementation of proof of stake. So if we go down here, we're going to see, let's see, the voting process, right? So this is under def vote. So this is the voting process right here. So because it's in Python, it's going to be downloaded by every node in the network. Every validator is going to be running this code. So under the vote function, we can see what does it take for validator to get to vote. So the vote message is going to be the vote for a validator. And so when a validator executes the vote function, that vote message is going to be input as the parameter to the function. So it's going to be, simply we can think of it as a binary yes, no, right? But it's a 1024 byte message. So it fits onto the blockchain. It's a very thin message. And once they've voted, then it's going to do these series of steps here to say whether or not the vote was valid. So the first step really is to say, let's start a dynasty. So let's start a dynasty. So a dynasty consists of a set of validators right here. And so once we have that dynasty, we're going to say, well, what is the overall vote of that dynasty? So another reason for having a dynasty is to say, what is the majority vote of this dynasty to speed up the voting process. So it's kind of similar to the electoral college in the United States. It's not that every single person votes, but it's kind of like a delegation of votes. And then what is the larger vote of this delegation? We send that up to the federal level. So it's kind of like that, but for proof of stake voting. So we say, okay, here's the current vote of the dynasty, which we're going to store in current dynasty. And once we have that, we can record that the validator voted for this target epoch so they can't again. So we'll have this record of whether or not the validator voted. They'll record that this vote took place. And then inside of the current dynasty, we'll increment all of those variables that we initialized earlier to say, well, the validator index, he voted, let's add one to it and then do it for the next validator. So there's some count of the number of validators in the network. And now that this validator is voted, increment the validator index to the next one. So we could say, okay, this new identity is going to be the next validator. So this is really the validation part right here. So once the validator is voted, if enough votes with the same source epoch and hash are made, then the hash value is justified. That means that if enough validators that have put stake into the system have voted, and those votes were indeed valid, then and only then can that vote be added, or that block be added to the blockchain, right? Because it is a valid vote. And that's essentially what this last part does. But yeah, there's quite a bit to proof of stake, but that's the general idea, and I just wanted to go into that for a second. But let's keep going here because we have quite a bit more to cover. So Wax. Wax is another cryptocurrency in this space. So these are essentially utility tokens that allow for virtual goods to easily be tokenized and exchanged for cryptocurrency. So any kind of in-game asset, whether that's, looking at the amount of shields that you got in some, medieval game, or some kind of map that you bought, or some skin for some new kind of, weapon in some kind of Counter-Strike-like game, anything like that. You can tokenize that and then sell it using this cryptocurrency. And you can link all of those in-game assets to this cryptocurrency so they're timestamped on the blockchain. And then you can have the name of it as well embedded in that 25-character hash. So it's provable. That's the point. So it's provable. So the Wax platform, they have a lot going for them. But what I find really interesting is how they raise their token sale. So if we look at their token sale, they raised quite a lot. They raised quite a lot of money. But the really interesting bit is that if we look at their token contract, it's essentially just a fork of the Zeppelin Solidity standard token contract. So Zeppelin basically makes making ERC20 tokens very, very easy. And if you look at this code, it's only 89 lines of code. And what they did was they just forked it, and they just added their own customized parameters to the code. So if we look in here, we say, okay, the constant name, it's a Wax token. Here's a symbol. Here's how many decimal points, so 8 decimal points. And here's the initial supply. And they used, scientific notation to say there are quite a lot of tokens. So if we look in all of these functions here, That's just it. It's just transfer. It's transfer from address, approve, increase approval, when not paused, decrease approval. There's only 7 functions in this code, and they raised at least 50 million USD. It's quite a lot of money, but it's just the power of ICOs, of tokens, of exchanges. There's quite a lot, and a lot of it isn't even justified. It's just people don't even understand what they're investing in. They just see something and they're like, okay, I need to pour a lot of money into this because it seems like it's good. But a lot of times it's really just smoke and mirrors. So we have to be very careful into what we invest in. And the best way to do that is not to look at landing pages. It's not to look at the hype around something. It's to look at the code. If you can do that, if you can understand the code behind some protocol, then you're set. Then and only then should you really invest a lot of money, because the code is really what matters, right? That's the real value that some unique token provides, right? If you have a bunch of coins for some space, whether that's esports or this or that, and there's 20 different players in the field, who is going to win, right? Who's going to be the token that the most people adopt? It's going to be the token that has the most value, right? And if all of them are just forks of the same token, who's going to win? It's the one that provides that unique code base. And that unique code base, that's not just unique, but it provides real value. And the best way to do that is to look at the code. So this is just kind of an analysis, an example of how you should be analyzing all of these tokens in the space. Let's keep going. So Unicoin, it's another one. Unicoin, bet, play, watch, same exact idea. It's for in-game assets for betting on the Ethereum blockchain. Interestingly, Mark Cuban invested in this, so they've got a $100 million token sale. Quite a lot of hype behind this one. But if we look in their token distribution contract, we'll see again, same thing, Zeppelin template, right? What's the difference between Unicoin and Wax? Nothing really. Programmatically, it's the same exact contract. They've got an ERC20, they've got a different landing page, they've skinned it, they've wrapped it differently, but under the hood, it's the same exact template. They have a different number of coins, they have this pre-sale token allocation cap, we have a post-sale token allocation cap, and they have a few more variables, but essentially it's the same thing. So it's really important to be able to look at these and say, how good something is and how good it's not. So let's go to the last one. So this one is really interesting. So it's called Chimera. And they say that this is the ultimate blockchain game development platform. But crucially, they don't have any code because they just don't have any code. It's just a landing page. But they're raising quite a lot of money from just a landing page, right? That's what I look for first is, do they have code? Yes, no. The answer is no. I'm just going to keep walking, right? So that's something you should do as well. Anyway, so I'm not saying that they're fraudulent. I'm just saying that this is something that helps investors. If you want people to invest, if you want more hype, have your code base available for people to view. So the idea is that you can take a video game, any kind of video game, and decentralize it on the blockchain. What do I mean? So if right now games are hosted on giant servers, World of Warcraft, for example, Blizzard owns the server, so you're connecting to Blizzard. If Blizzard decides to stop, maintaining World of Warcraft, then everybody doesn't get to play anymore. But in a decentralized space, there are multiple servers holding this game, and people can interact with each other in a peer-to-peer way. There's no way to shut the game down. Also, if you're an indie game developer, then the cost of the infrastructure to get your game out there in front of many, many people, it's a lot. So you might be thinking, how are they putting an entire game on the blockchain, right? Games are multiple gigabytes of data. They're not. And if you have any kind of game that's related to the blockchain, you shouldn't put it on the blockchain. Just try. It's not going to work. It's too big, right? Blockchains are very, very thin clients. And to have every node in a network download a game, it's preposterous. It's not going to work. What should you do instead? Well, you should use what's called a distributed hash table to store the data. What the blockchain is for application level constructs. So usernames, tweets, anything that the network has to agree upon, game states. That's what you would use a blockchain for. So application level constructs go on the blockchain. The data itself is stored in a distributed hash table like IPFS. So that's how they should do it. I don't know how exactly they're doing it. They weren't very specific, but they have this idea of game channels. So game channels are what are called off-chain transactions. So in the Bitcoin network, there's this concept of a lightning network. And the lightning network says, I'm a node, you're a node. Let me transfer you some value without it going on the Bitcoin blockchain. So it's just a peer-to-peer node. What's going on the blockchain is a record of that transaction, but it's a very thin record. It's not a huge record. Like a normal blockchain transaction takes a lot of time, right? There's a lot of time involved in a transaction, at least 10 minutes at this point, but that's too long. And so the reason they call it a Lightning Network is because it's very fast, because it avoids using a blockchain. It's a direct peer-to-peer transfer without it being on the chain. So they're using this concept to store game states very fast, because game states need to be fast in terms of a game, right? If you're in position A, you need to go to position B. The network needs to agree that you moved, but you need to do this in a fast way. Game channels are the way to go. But if we look at this code here, let's look at some code. So even though they don't have any code available, I did find some game contract code. So this is a protocol called IZX, and it's a game protocol that uses smart contracts to agree on application level constructs. So they have 4 different smart contracts, which is very interesting, and I think this is a good way to do things. They have one which is called game, and that's defining the base abstract concept of your game. You have token game, which defines the game's token, rev share game, and so this is an example of how to share that value between players, and then game controller. So this is this controls which token holder has what and to what extent they can participate in the game. And they have contracts for all of this in Solidity, but interestingly, the game contract is probably the one that we should be looking at right now. So up here they have some rules of the game, like 2 rules essentially. The game issuer places the number of prizes into the contract and the seed to calculate those hashes. They're unknown and kept in secret. So once players play the game, the issuer may give a secret seed to the winner. The winner claims a prize and gets a reward. So this is an example of using an application level construct for something that's essentially a massively online multiplayer game, right? Keep the thin stuff in the smart contracts, the big stuff in the distributed hash table, and we're good to go. Anyway, I hope you found this video useful, and please subscribe for more programming videos. For now, I've got to visit Decentraland, so thanks for watching.